privilege to introduce Toby today. He's a very good friend of mine, and we've known him for over 10 years. I sit in his Sunday school class every Sunday, so he's a great guy. Okay, about Toby. Toby has a Bachelor's of Science in Engineering Geophysics from the University of Oklahoma. He joined Shell Oil Offshore Division in New Orleans in 1980 as a geophysicist, and he's serving many assignments in seismic acquisition, processing, R&D, interpretation, exploration, and development before retiring after 39 years as a Shell manager for geophysics and subsurface vendor liaison for the Americas in Houston. It's a long title, Toby. From the outset of the Shell's leading position in creation of the deep water oil and gas exploration, development, and production industry, Toby was blessed to participate in many others in helping Shell identify, deploy many new seismic and compute technology to discover and develop billions of barrels of oil or gas reserved in the Gulf of Mexico, the Americas, and around the world. After retiring from Shell in December 2018, he has worked as an oil and gas consultant to several companies. Toby and his wife Cindy, deceased now, were blessed to receive and home educate 5 children, and now I'm blessed with 4 grandchildren. Of course, he coached more than 50 seasons of Little League sports and has been a Baptist deacon and Bible teacher for almost 40 years. His current research interests includes history, science, worldview, and current events. And Toby, with this, it's your floor.
Okay, thank you, Margaret. Thank you, Salim, and thank you, Carlos. I appreciate the invitation and the opportunity to share with you. Let me share my screen and we can get started here. Let's see. All right. Okay. Hopefully you can see my screen now.
Mm-hmm. We can.
And I will put my presentation into presentation mode here, and we can go from there.
Mm-hmm.
So Margaret asked me to consider giving this talk. It's a very interesting group that you have here. Pay it forward. I hope that I'll give you something that you can pay forward here, but I really want to just share with you some thoughts about my career in the oil industry for 39 years and since I left the industry a year and a half ago. So I came up with this really long title, and it's always a dangerous thing to have a long title before you have a paper. So I always like to have an alternate title. So here's the title: Recognizing and Defining Oil and Gas Exploration and Production Business Problems and Developing and Applying Technologies to Solve Them. But the alternate title is this, is that it really is cowboy wisdom versus conventional wisdom. That's a little short aphorism for it. And I want to just make my disclaimer here. I know we're dealing in a world that is much more woke than I have been in my life, but these views are expressed by the presenter alone and are intended to stimulate intellectual contemplation, not to offend. So I hope my language is not offensive to those that are listening. As Margaret has given my introduction in terms of my bio, I really want to just try to talk to you about this, is that in its 160 years plus of existence, the oil and gas industry has been confronted with and has frequently overcome hundreds of difficult business and technical problems in the value chain of its business: finding, developing, producing, transporting, refining, marketing, and in recent times, government relations. So I hope to just share with you, based on my experiences, really even started in college, working in summers for a refinery, oil refinery, that led me to conclude that timely and cost-effective solutions to problems depend on several key factors, including deep scientific and technical knowledge, an accurate understanding of market conditions and requirements, an integrated cross-disciplinary commitment to sound physical, chemical, and scientific principles, proven and believed core values, convictions, and work processes, and the ability to recognize the discontinuities required to identify and define the true problem versus many postulated problems. And once properly identified and defined, the solution space can be quickly narrowed to a few realistic possibilities for investigation and prototyping. I don't have time to show several examples, but I want to show you specifically one example from my career with regard to this. So here are the elements of my talk, sort of my outline. First, I want to give you an introduction, talk about some context, and then first principles, and really kind of talk to you about these cowboy wisdom that has kind of been my guiding principles for my entire career here. Talk to you briefly, just review for you a little bit of history, the beginnings of the oil and gas industry, and then look at some key technology solutions that have been developed over the last 160 years, and then really talk about a timely, cost-effective problem resolution. And then I want to give you an example from 1984. It's 35 years ago, but it's a very interesting example. I think one that we can continue to learn from. Just talk about some extended technology solutions, and then also just try to come to a couple of conclusions, and then invite your questions and discussions. Margaret has already given my bio here, so I'll pass along this, but it's been a very enjoyable career. I've had a great time in the industry, and with not only my Shell colleagues, which was my entire career, but also with my colleagues in industry that I worked with other majors as well as vendors. So one thing I want to just remind you, and I just hope you have this sense, I have really spent the last 10 years of my career really trying to encourage young people that it's important for us to not get caught up in the noise that we hear in our culture and that sort of thing. And I will make this statement, I believe this is true, that in fact the oil industry is necessary for human flourishing. The oil industry is necessary for human flourishing. Why do I say that? The availability of affordable, reliable energy provided by hydrocarbon exploration, development, production, refineries has been the single greatest enabler for the advancement of human civilization, i.e. human flourishing in the past 150 years. Why is that? It's because you can take a barrel of oil and you can do more things with it than virtually any other thing that we know in terms of transportation, a huge amount of transportation, in terms of energy, power for providing electricity and providing air conditioning and other kinds of things. And then of course also lastly for the petrochemical industry, for plastics and other things that are necessary for our civilization to advance. Now this has of course come under a tremendous amount of attack in the last 10 years in particular, and we hear things, lots of issues and concerns about this. I just want to give this corollary, and I'll just lay my cards on the table right here. There is no definitive evidence of man-caused global warming. I'll try to, this is not a global warming talk, but it's always necessary these days when you talk about the oil industry to at least make reference to that. And many of you may have a different view of this. I'm happy to have an offline conversation with any of you about it, but I think it's an important thing for us to keep in mind. The other thing that is important for us to understand regards the oil industry that is necessary for human flourishing is this, is that the value is this, is that the potential energy that exists in a barrel of oil or in a molecule of oil far exceeds any other energy possibility that we have. This is a very interesting paper by Bradley Layton, a mechanical engineering professor at Drexel University a few years ago. Comparison of energy densities of prevalent energy sources in units of joules per cubic meter. And in this, he makes a very interesting statement. I'll just read this very interesting paper. He said, a single gallon of gasoline contains approximately 40 megajoules of chemical energy. Dividing energy by volume yields an energy density of 10 billion joules per cubic meter. Gasoline is 10 quadrillion times more energy dense than solar radiation, 1 billion times more energy dense than wind and water power, and 10 million times more energy dense than human power. So the power of having a molecule of hydrocarbons is so huge in terms of its potential energy, and that's why it's been so valued and so important in the pursuit of society over the last 150 years, and been put to use in so many ways to help us. So let's look now at some of these things. I always like to use this little chart to talk to my children and my children's people of my children's generation, their friends and other things, is that if you just go back to the year 1900 in the USA, the average lifespan in the USA was 43 years. That's how old you got on average to survive. Of course, that was also due to a lot of infant mortality and child mortality and other kinds of things. But today we're at 78 years. It's interesting that in the past 2 or 3 years, actually our lifespan is becoming shorter now for various reasons. Very interesting by a year or two. The standard of living, in 1900 we had very little electricity, few labor-saving devices, poor sanitation, few medicines, and slow transportation. But now today we have almost universal electricity, washing machines, bathrooms, indoor plumbing is a huge thing, antibiotics and medical care, cars and air travel. In 1900, the average education in this country was 8th grade. Today, average is beyond high school with a high degree with college and higher degrees. And in communications, of course, all of our children believe that civilization is based on having a smartphone and internet access, and that's certainly what we have today, as opposed to those were not even thought of, even 30 years ago. So very interesting. So I want to just briefly address this question of there's no definitive evidence of global warming, of man-caused global warming, and I think this is good news in the year 2020. I really like this guy right here. I encourage you to read his book. Alex Epstein is his name. It's called The Moral Case for Fossil Fuels. This young guy doesn't have any connection to the energy industry, but he's become very aware of the value of fossil fuels and the importance of them. And he's really gone out of his way. He's testified before Congress. He's done lots of things. He's done lots of different videos you can watch on YouTube. Very interesting. And when I was working still at Shell, it was required viewing by my young staff when they came in to look at his testimony before Congress a few years ago. I thought it was really, really good. Definitely worth the time and effort. But in recent days, it's been very interesting. I don't know if you've seen this, just as happened here in the last month. This guy, Michael Schellenberger, who's a renowned green activist, he apologizes for the climate scare. He says this, that in fact, on behalf of environmentalists everywhere, I'd like to formally apologize for the climate scare we've created over the last 30 years. Climate change is happening. That's an interesting point. I would say true, climate change is happening because climate change has always been happening. But it's not the end of the world, nor is it our most serious environmental problem. In reality, we know that now that these are facts now, that these are facts that few people know. Humans are not causing a sixth mass extinction of animals. The Amazon is not the lungs of the world. Climate change is not making natural disasters work. And there's a whole litany of these statements that if we look in our conventional media, or we look on Twitter or other kinds of things, we see over and over again, just really how misinformed and how politically motivated so many people are. And what that has caused is it's caused the investment of, tragically, in the Western world, trillions and trillions of dollars that in my mind have been ill invested. There are many other ways to do this, to do a better job of this. And in fact, the whole question of carbon emissions is one that has been a challenge. We know that carbon dioxide in the atmosphere historically, there have been times where it's been much higher than it is today, and temperatures have been much higher than they have today, even as much as 6 degrees, not 0.2 degrees, which is what the concerns are for the Kyoto protocols and other kinds of things. So I'd encourage you to follow up on Michael Schellenberger. He, interestingly, has not jumped on the fossil fuels bandwagon. He's a nuclear guy now, but he still has some very interesting things to say. It's a very nice TED Talk to see about this. The other guy that I like is these guys at Clear Energy Alliance. I'd encourage you to go look at their videos. They're like PragerU videos, 5-minute videos, but they really talk about the oil industry and the value of it and the danger of these green energy initiatives that we have ongoing today. So that's my statement about global warming. I know there's many more, and perhaps I've offended you. I apologize for that, but I think you need to consider that. So one of the things I want to encourage us to do is continue to look at and periodically derive our existence on first principles. The idea of the red thread of the fight for us in the oil industry. So our hope in the oil industry, oil and gas industry, is improving the human condition and our ability to be good stewards of our global environment, because as we see people become have more energy available, they actually become better stewards of the global environment. We see that all the time when we travel to the third world, as I've been privileged to do, go to places in Africa and in South America where they just have a lot of energy poverty, and as a result of that, it's very difficult for them to survive from one day to the next, and let alone take care of the environment. So that depends on the availability of cheap and reliable energy for everyone. And of course, we see this everywhere. When you increase, this is some charts, there are thousands of these charts. You look at the use of fossil fuels, in this case in India and China, and as fossil fuels go up, we see a corresponding increase in life expectancy and other kinds of things. The quality of life continues to go up. But for us in the oil industry and for the service industry and everybody else, the fight is really this titanic struggle has always been to get the earth to yield its energy wealth profitably for mankind. We have to be able to find the oil, we have to be able to produce the oil, and we have to be able to market the oil in a way that actually results in somebody making some money on it. And yet what we see is that there's a continuing increased demand. We'll talk more about that as we go into the future, but we're going to see that demand for energy is going to continue to grow in the world. Now, what I want to just show you here is the Gulf of Mexico, which is one of the places that I spent a lot of time in my career. And what you see is this down at the very bottom is a chart of oil production on a daily basis from an annual basis from 1970 all the way up until projected into 2060. And what you see is that the bulk of the production in the 70s and 80s was on the shelf up in water depths less than 600 feet in the U.S. Gulf of Mexico. And then since then, we've seen a change in that production as we've moved out to deep water. I want to talk to you more about that as we go. But as we do that, I want to remind you about this whole idea of cowboy wisdom. These are really the principles that you ought to keep in mind as you go forward and as you begin to look at any particular problem that you have, not just in business, but also in life. And one of the things that's important is water always flows downhill, at least on Earth it does. Now, if you go out in space, it's a different story. So it depends on your frame of reference a little bit, but gravity and physics always work. So there are many times I'd walk into an office where I'd see somebody that was looking at a map and looking at trying to understand what the subsurface was telling them. And you could see obviously that they had forgotten these simple ideas that gravity and physics work. So it's important to keep those in mind always. The next thing is the spectrum of truth. And this is one of the things we've seen really very, very powerfully in the midst of our whole COVID crisis that we're dealing with, is that there are facts, and facts are much, much more important than models, which are much more important than theories if the models are near correct, certainly more important than opinions. And if you work with geologists, it's much, much more important than geologic ideas. So we want to focus on facts and not get ourselves in a place where we're depending on models. We've certainly seen that has been the case tragically in this COVID case, where every model ever done has been completely wrong from almost from the beginning. Secondly, you can tell now, or thirdly, I'm a geophysicist, so I'll tell you this, that seismic's the lifeblood of the EP business. I used to tell all my friends in development and in production all the time that it was important for them to understand that everything that we're doing in the downstream from exploration fundamentally started with the seismic data, at least in the offshore for sure, as well as in other places. Next, we see farther because we stand on the shoulders of giants. There's been a huge amount of effort in the industry to build the oil and gas technology and capability, markets, and other kinds of things like that. So we really are blessed by having a great history where people have done some tremendous things that we can stand on the shoulders of. Next is this, is a little bit of a philosophy to keep in mind, but I think it's really good. You can't tell how good a person or a watermelon is until they get thumped. This is an important point. Character shows up best when tested. All of us are going to be tested just like our culture is today with these tragic riots and other things that are happening in our country. And the question is going to be, what kind of character are we going to show as we've been thumped? And that's an important one. Next is never take down a fence unless you know why it's there. I think you could translate that to never take down a statue unless you know why it's there. Try to understand what you're doing as you go through. It's easy to tear stuff up. It's awfully hard sometimes when the cows have gotten out to get them back in. That's not fun. I've spent a lot of midnight hours trying to round up my granddad's cattle whenever the fence came down and the cattle got in the road. It was not too fun. So next is you choose the hill you die on. This is an important point for us to always consider, to think about. There are certain things that are definitely worth the energy and the effort, but you can't die on every hill. You have to make a choice relative to what's important. Next is there's more to life and oil and gas than we can currently see. So don't ever, ever, ever give up. I think that's one foundational statement of my career, and one that I think is truly important. There's a little bonus here. Don't blink. Life is short. Fear God, do right, and have fun. I have to tell you, it was mentioned by Margaret earlier. My wife and I, she supported me, and we had a great marriage for 38 and a half years. I retired in December 2018. She found out in January 2019 she had pancreatic cancer. She fought long and hard and passed sadly in February this year after 13 months of the fight. So you just don't know what's going to happen in your life, so you need to be prepared to enjoy every day. Each day is a blessing, and you need to do right and have fun in each one of those. So with that, in the oil industry, I have to tell you, it's been a very interesting ride for us since the 1860s. The Colonel Drake well, if you remember, was drilled in 1859. We'll talk about that in just a minute. These are prices normalized to, I think, 2014. And I just wanted to show you something kind of interesting. This is my career, and you can see that there's been no such thing as a stable price in all of my career. And in fact, I used to tell the young guys is that today we're at $40 a barrel, and I have to tell you, for the bulk of my career, we would have killed to have $40 a barrel oil. So there's negative things about low prices, but in fact, there's always opportunities to make money here as you go forward in the oil business. So let's look now at the beginnings of the oil and gas business. So let's see where we are. There have been small amounts of petroleum have been used throughout history. The Egyptians coated their mummies with it. They sealed their pyramids with it. The Babylonians, Assyrians, and Persians used to bathe their streets and hold their walls and buildings together. Boats in the Euphrates were constructed with woven reeds sealed in pitch. Chinese came across it while digging holes for salt water and used petroleum for heating. The Bible says that Noah used pitch to make his ark seaworthy. American Indians use it for paint, fuel, and medicine. Desert nomads use it to treat camels for mange. In the Holy Roman Empire, Charles V used it to treat his gout. Then Persians and Sumatrans also believed it had medicinal value, but of course it didn't taste that well. So the fact of the matter is they've always had petroleum. People have always coveted it, seen the value of it, but tragically they haven't been able to access it, large volumes of it, to use it for lots. So for thousands of years, petroleum is scarce. And what this guy George Bissell found in a lawyer in the 1850s said that we need to find more oil, and he lived in Pittsburgh, Pennsylvania, and they found this area in Titusville where there were some oil seeps into the creek right there. They turned out they called it Oil Creek. And then they actually employed Edwin Drake, who they started calling Colonel, and he found oil by drilling his salt well or using salt tools at 69.5 feet deep. So it's a very shallow well, but he found that well production. Now, I have to tell you, that's in 1859, but we have documentation that in 347 AD, oil wells were drilled in China up to 800 feet deep using bits attached to bamboo poles. I have no idea how the Chinese did that, but that is such an amazing statement to me. They were able to drill a hole 800 feet deep to find oil. And of course, we know about Baku and the importance of it in Azerbaijan in terms of the oil industry. And as early as the 1500s, they were hand digging wells up to 115 feet deep to be able to produce oil. And then we go further down in 1848, first modern wells drilled in Asia near Baku. We see then that, in fact, the idea of processing the oil, the distillation of kerosene by 1849, and then we see, of course, the first well in the U.S. in 1859. Of course, we live here in Texas here, and one of the reasons we do is because of what happened in January 10th of 1901, the Spindletop Gusher, which actually started the Texas oil industry, even though there had been a couple of other fields found. It was Spindletop that suddenly overnight doubled the world's oil production, was making 800,000 barrels of oil, the first well, which is just amazing in just 8 days. So incredible volumes. And then suddenly we had a way to begin to make enough oil to use in great places. And so as a result of that, then we found that Daimler Motor Company was able to create gasoline engines by 1891. And then we see a whole series of key technology solutions over the years. We see Howard Hughes Sr. actually invented the first roller cone drill bit in the year 1909. We see logging going on with in 1927 and catalytic cracking in 1935. Huge amounts of things going on. And by the 1940s already, we're drilling in the offshore. And by 50s, we have jackup drilling rigs. The Gulf of Mexico begins to open up in the 40s and 50s. We see Shell actually experimenting. Shell made a giant steel dome in 1961 in the Gulf of Mexico, sunk that thing and sent divers down there. They actually would go into the dome and actually work without any air support. Is a very interesting thing. I talked to an old guy, Charlie Wickheiser, who was a Shell engineer that was part of that project. Really an amazing thing. But in the end, it didn't work because it was just, one, it was costly, but secondly, it was also just so dangerous because a spark could start the fire, similar to what happened with Apollo 1 and kill people. It didn't happen, but they knew it had the potential to do so. 62, we see a semi-submersible drilling rig. And then by 1970, the seismic begins to really become quantitative as well as qualitative and give us a sense of what we can actually do in terms of seeing the subsurface and being able to make a prediction as to what it actually is telling us with regard to oil and gas accumulations. The Trans-Alaska Pipeline completed in 1977. It's incredible that all these things were going on. In 1978, Shell deployed the Cognac platform in 1,100 feet of water, an amazing feat of technology. By 82, we're seeing 3D seismic, 83 subsalt drilling, just incredible things. And then we're beginning to make discoveries in the subsalt by the 90s. And then we're seeing the first floating production facility at Auger, Shell field in 1993. And then we're beginning to use seismic in a more sophisticated way to actually make sense of what our time lapse of how the data would change. LNG, a huge change in terms of the market, the ability to take this stranded natural gas, turn it into liquid and ship it around the world, incredible. And then we see in the 90s and the 2000s, additional things moving out into deeper water with the semi-submersible host facility at Nikika in the year 2003, and then continue to drill deeper and deeper water, 10,000 feet of water in 2011. And then we're seeing wells that are producing unbelievably down in the Campos Basin by Petrobras, 60,000 barrels a day of production out of those deep wells. Just really incredible. So lots of very amazing technologies that have been developed over the years in response of the fact that we find the accumulations of hydrocarbons, and there's a market that we can actually market to, and then we need to develop new and different technologies to be able to access that oil. So what do we say in terms of recognizing and defining oil and gas problems and developing and applying those technologies to solve them? My contention is, first, you need deep scientific and technical knowledge. It's really important that we spend our time learning about the physics, learning about the chemistry, learning about the nature of the science that we're dealing with, the whole challenge of how to understand what's really happening physically to the earth is a fundamental question that is necessary in order to be able to define the real problems. These are critical, and my encouragement has always been to young staff is to, spend your time building deep scientific and technical knowledge. I have to say I don't have a PhD, but Shell gave me the equivalent of 2 or 3 of them in the projects, the R&D projects that we worked on in the early years of my career, where we were struggling to understand the physics of what was happening with, in particular with our seismic, and to try to be able to use it to be able to help us understand what was happening in the subsurface. We also need an accurate understanding of market conditions and requirements. The problem has always been that we would love to have $100 barrel oil all the time, but we just don't have that. So it's important for us to build cost-effective measures. And in fact, I have to say that we have a lot in kin in the oil industry with the moonshots of the 1960s because of the fact that they had to operate based on a low price vendor kind of a market and idea to build their rockets and other kinds of things like that. So there's always a challenge to try to bring things in a cost-effective manner, or at least if not a cost-effective manner, then we have to figure out, well, how do we actually bring value on more expensive technologies? That's always been a big conversation of, I can use more expensive technology, but I'm really going to be able to get value from it. And I can know that you folks, particularly in Schlumberger, that's always been a challenge for you, and I have great admiration for your company and for your technology because you've worked hard to try to enable that to be the case for us in the industry. And we also need an integrated cross-disciplinary commitment to sound physical, chemical, and scientific principles. Nothing like a good cross-disciplinary team of, in the case of the oil industry, geophysics, geology, petrophysics, reservoir engineering, as well as other kinds of engineering, well engineering and other things to be able to help us to understand all the facets of a problem to be able to bring an oil field online in a cost-effective manner. Next, we need to be able to see proven and developed core values that proven and believed core values that all of us agree to and understand. This leads us to conviction and then a commitment to work processes. We at Shell, many times we're criticized for having too many work processes, and in fact, they are somewhat cumbersome at the beginning when you learn them, but you'll find out that it's really important to help you with develop a language where you can talk to other people who are in business development, finance, even in the case of employee relations and other kinds of things, to be committed to a work process that enables us to be able to see the way to what the end is, an important point. And then lastly, you need an ability to recognize the discontinuities required to adequately identify and define the true problem versus many possible postulated problems. This is where a lot of time and effort is spent in the industry, but it's a real challenge. There are many ways to solve a problem, but it's important to be able to see what are the key elements of the problem that need to be solved and not just sort of doing research for the sake of research. And we wound up with a lot of those, unfortunately, failed efforts over the years in Shell, where we started pursuing research for research's sake, really not tied to a particular business problem that we needed to try to develop and understand. So my advice to early career engineers and geophysicists and professionals is that information is what you need to make money, but knowledge is deeper understanding of how things work, and it's attained by long and arduous study, setting aside a profit motive, having intrinsic desire just to know, and to choose knowledge over information. I think it's an important statement for us to make and keep in mind. And then also, here's an illustration there, one of many of these of the workflow that is very important. This is in the case of choosing front-end engineering projects and looking for a design. What kind of particular design do we need? So you look at feasibility studies to assess You select the concept, then you define, and then you execute. You guys are very familiar with this. Very important things for us to follow as we go forward. Now, this is an interesting thing I just saw in this month's AAPG Explorer. That the key article in there this month is the Gulf of Mexico is still a standout for super basin exploration, which is a kind of a shocking thing because the Gulf of Mexico exploration started in the 1940s, and here we are in 2020, and they're still making that statement. But what I want to do is I want to talk to you about where we were in 1984 to define what the problem was, and then to look at this question of conventional wisdom, which ultimately gives us this challenge of understanding this discontinuity and then trying to make application to overcome it. And so this is what the problem was. I remember, and I have in my notes, there was a vice president of Shell Southern Region in New Orleans where I was working at the time in 1984. His name was Billy Flowers, and Billy Flowers had worked in the offshore in the Gulf of Mexico from 1949. So almost from the very beginning, he was working in Shell in the offshore division. And I retired in the year 2020, or 2018. So between the two of us, Mr. Flowers and I have covered the whole offshore industry up until at least through 2018. Now, the interesting thing was what Mr. Flowers was seeing, and in his sort of summary statements, he was talking about the success of Shell and others in industry in the U.S. Gulf of Mexico on the shelf. But at that time, and this is a production chart that was developed in 2012, but in that time, what Mr. Flowers was seeing and what Shell management was seeing was this thing going into this precipitous decline starting in about 1990. Now, it was extended based on a lot of good work and technology work up until the year 2000, but it still fell off. So, but Mr. Flowers and senior leaders in Shell were looking at this kind of production, and they were seeing that in 5 years it was going to fall off. And so they were very concerned about, well, what's going to be the future of the company? Certainly I was concerned because I started in 1980, and it was the very early days of my career. And those of you who are familiar with that, have heard of that, we really began to see the first layoffs in the oil industry, and the first layoffs since the 1960s, starting in sort of 85, 86, because of this precipitous fall off. Now, Shell saw that, and Shell management was very aggressive trying to overcome that. And so they saw that the Shell production would begin to fall in 1990. We need a new play in the Americas, and they spent hundreds of millions of dollars in offshore Alaska, the U.S. East Coast, offshore California, even the Columbia Plateau up in Washington and Oregon. And then we also looked at the Gulf of Mexico deep water. We made big investments there. I actually rode seismic boats off the U.S. East Coast and had some great crew changes in places like New Bedford, Massachusetts, and Brunswick, Georgia, and all kinds of interesting places. But tragically, none of those really panned out, with the exception of the Gulf of Mexico deep water. And what I want to talk to you about is how that actually came to be the case, and then tell you kind of where it's at. So the problem in '84 was that, in fact, we are seeing a decline. We actually went out and shot a bunch of seismic data, regional seismic data, and it came back with this. We see bright spots in the Gulf of Mexico deep water. That was the observation. The challenge was for us is that those bright spots, which up on the shelf had been used for 15 years or so, to actually help us to find and drill and develop hydrocarbon accumulations and turn them into fields and turn them into production. But the challenge for all of us was seeing these bright spots. Does that mean these are hydrocarbons? Does that mean these are hydrocarbons? Does that mean it's oil? Does that mean it's gas? We just didn't know. We didn't have a calibration. It became a real challenge for us. Here's a picture. This is the first seismic line shot over, or first Shell seismic line anyway, shot over Ursa, which is a deep water field near Mars, in the most prolific of all the deep water basins, really in the Gulf of Mexico, and certainly in the world until the Brazilians get their production going in the deep water pre-salt game. But these seismic line is showing us bright spots that we would, if set up on the shelf, would say these are clearly hydrocarbon accumulations, but people did not believe it at the time because they had a number of elements of conventional wisdom that we had to sort of look at and overcome. Today, we now know that the deep water has been pervasive throughout all of the Gulf of Mexico, and we've seen it, we've exported it to Africa, we've exported it to Nigeria, to Brazil, we've exported it to Mexico. So there's been a lot of work to take that, but in 1984, none of that was yet to happen. So here was the conventional wisdom in 1984. These are the things that we needed to come up with to try to understand what can we do here. One is that there are no large grain sediments in water depths deeper than 1,200 feet. We had the Cognac deep water facility. It was in 1,100 feet of water, but it was right at the mouth of the Mississippi River. So people thought it was just kind of a fluke because of this steep roll off here, and just didn't feel like there was going to be any sand out there in the deep water at all. Then also that there was not only not sand, but there was no oil out in the deep water Gulf of Mexico. We didn't have a petroleum system that actually would support that. And then there's a problem in the Miocene in the deep water Gulf of Mexico. There's a problem with source, there's a problem with charge, there's a problem with trap, there's a problem with reservoir, there's a problem with fluid, lots of problems with the Miocene section there, which has now become the most prolific of all the deep water sections in the Gulf of Mexico. And then next, significant oil and gas accumulations cannot occur in apparent synclines. It's a violation of Charles's law. What we were seeing is that we were seeing places where that brightening was occurring in the base of synclines, at the bottom of hills, if you will, rather than on the top of hills in anticline structures that would be more indicative of a traditional oil field. We didn't understand what was happening there. And then fifth is, even if you drill a discovery, we'll never have the technology to develop and produce enough volumes to make any money in those kind of water depths. That was a real challenge. Things were just going to be too costly to develop, even if you could develop those things. And then lastly, and I heard this over and over again by our drilling engineers and our well engineers, no well in the Gulf of Mexico will ever make more than 6,000 barrels a day. The problem with that is, if we can only make 6,000 barrels a day, if that's the most we can make, we can never pay for these expensive deep water developments. So these were the conventional wisdom items from all disciplines that we were struggling with to try to overcome in 1984. So here's what we wound up doing then, is that we took this seismic line and we looked for the opportunity to try to understand, well, what could it mean? And so we began to look in places to try to find solutions to overcome this conventional wisdom. So let's look at that first one. There are no large grade sediments in water depths deeper than 1,200 feet. Well, that's been refuted by the USGS deep sea drilling project. What we had is that we went out, industry funded, and USGS was a part of a drill ship that could go and make shallow cores in the seafloor in deep water, and they began to core all over the world. But when they went out to the Gulf of Mexico, and you can see just south of the river here, the mouth of the river, you see that these are where the deep sea drilling projects actually occurred. The samples that they took out here on the Mississippi Fan, and what they found is in several of these cores, they found at the very bottom of these cores, these are basically in a couple of 100 feet deep, and in the very bottom of these cores, they found gravel. And the problem with that gravel is that that was completely unexplained, that you could get gravel. There's no way the Mississippi River, even if it were 100 times as big as it is today, could deposit gravel out there, is what they said. So how in the world did you get gravel out there? And the joke at the time is that the chief geologist of Shell had said, when we looked at these cores, he said, the only thing I can expect is that a pirate ship came by and dumped its ballast. That's the only thing we can figure out how to sample it, because there's just no way to get gravel out there. We were completely confused by this, having heavy grain sediments. That, of course, is before we knew what turbidites were, and we realized that turbidite flows actually can be very, very powerful and can carry large grain sediments around, which has been a huge impetus for the deep water. Next is there's no sand or oil in the deep water Gulf of Mexico, but that's been refuted really by the Venus well that was drilled by Exxon Mobil in Mississippi Canyon 852, or excuse me, drilled by Getty and Exxon Mobil in June of '84. Very interesting well. It was a really powerful well and a really courageous well for Getty and Exxon to go out and drill. This is the modern day Mars Basin. Mars sits right in here and Ursa sits right over here. But they drilled, as you ought to, they drilled an anticline on top of this salt dome right here, and they drilled all the way down and touched the salt. The interesting thing about drilling right there in that location was, here's the log. This was a huge, big battle, secret log that happened in '84 and was very tight. And in those days, still the case that logs become public in 2 years. But there were all kinds of scouts out there watching that well to see if, in fact, they would have a discovery. And we found out later when we finally got to see the log, they drilled all the way down and they found at the very below, just before they entered salt, they tagged the sand. That was a good quality sand with 6 feet of, or this says 4 feet of oil. I thought it was 6 feet of oil. 4 feet of oil in it, and that oil was good oil. And the fact is that it certainly was sub-commercial. We couldn't make any money on 4 feet of oil. And as a result of that, Getty and Exxon, they encountered that oil in a 29% porosity, good oil, but it was non-commercial. And as a result of that, Exxon and Getty condemned this basin, and they said there's just no way that there's enough for us to go here, because it's a very expensive well drilled in 3,500 feet of water in those days, and they reduced their exploration efforts in the deep water. But Shell, when we got a hold of this, based on the seismic data that we had, this gave us a calibration to say, our seismic is giving us indication that in fact we are seeing hydrocarbons here. So Exxon and Getty condemned their play in this area. Shell got very excited, and we began to push really hard to try to get there. And in fact, today, if you draw a circle about 10 miles in radius around this area, what you find is there's probably a total of 10 billion barrels in place here that we actually went out and pursued in terms of looking at, because this proved the hydrocarbon system, proved there's oil in the deep water Gulf of Mexico. We didn't know exactly how it got there, but it was based on this, we went out and became very aggressive in the lease sales. So the other conventional wisdom is there's a problem with the Miocene in the Gulf of Mexico. What we found was the Miocene is very shallow up here, and we know there are source rocks way down here deep, and we just don't know how to get charge from this level up into the Miocene in a much shallower level out in the deep water, because you got to have a way to be able to get conduits of this oil and gas as it goes through. And then what we found is that in fact in the Garden Bank 754 Hess number 1 well, finally in the year 2000, we went for 20 years not knowing where the source rock was. But in the Norton well in Garden Banks 754, we see this rafted sediment section from way deep, where we actually see these Jurassic and Mesozoic source rocks that we'd never seen before in that well. So Shell management actually looked at this problem and realized we can't solve this problem unless we have more data. So they fundamentally basically just ignored these questions and began to trust, based on the Venus well, these seismic anomalies as bright spots. And as a result of that, we did a lot of work, a lot of technical work, trying to quantify, because we wanted oil, we didn't want gas. But at that point, we said we believe the physics of seismology. Once we understand the rock properties, can reveal the presence of hydrocarbons in the subsurface. This has been work that was done back in the early 1900s, and then by direct understanding and measurement up on the shelf as bright spots. And so we believe these bright spots would work. Next, we said significant oil and gas accumulations cannot occur in apparent synclines. This was refuted by the Mars Discovery well in 1988. And the idea is that what we saw was 1989, sorry, that we saw that this was the seismic data. This is showing these bright events down here in an apparent syncline, but in reality, it was because the structure was hard to see on 2D data. We needed fully 3D data to understand that it was not a syncline. It actually had a synclinal element to it, but in fact, there was a down dip fit to structure on the water level. And so we could actually find the fact that the physics did actually work. Oil does, gravity does continue to work even out here. And as a result of that, we found a huge upside in terms of Mars. And we found this little adage that the big ones always get bigger. Next is, even if you drill a discovery, we'll never have the technology to develop and produce enough volumes to make any money. This was refuted by Shell, many other majors. Here's a list of all of the Shell platforms in the deep water, TLPs and other spars that have been built. This is a huge industry, so amazing to see these things and to see the engineering required here to do this is just a real credit. And as a result of that, we're seeing these fields making, you know, hundreds of thousands of barrels of oil every day. And so we can, if we can find enough molecules, we can develop and the technology to drill, develop, and produce profitably. And then lastly, this question of oil will never have a well make more than 6,000 barrels a day. Well, now there are so many wells that have produced more than 6,000 barrels a day because of the friendly nature of the turbidite sands, their continuity, as well as the fact that they've got pressure support from water legs. That in fact, these things will create unbelievable volumes, up to 40,000 barrels a day. And as I mentioned earlier, down in Brazil, they're finding 60,000 barrels a day. So these turbidite sands are much more prolific than anyone ever expected. So what we've seen then is the reliance on technology in seismic and in drilling has enabled us to be able to see, understand, and access these hydrocarbons in order to be able to completely change the shelf production, convert it to a new play, a new concept, a new idea, deep water production. And we now see that this is going to continue to raise. And in fact, this is an old profile. It's actually gone even steeper than this based on the follow-on work in the Miocene as well as in the Paleogene, as well as around the world. So very powerful, great story about technology. And then, as I said earlier, just incredible story of what's happened in terms of the ability to develop structures and ideas to be able to actually come up with these things that are now, Stones is out there in almost 9,000 feet of water. It's just amazing facilities that have been designed. Each one of these is sort of a one-off idea, but it's so powerful in terms of its ability to access what's needed at the water depths it's needed, from Cognac and Bullwinkle here, 78, 88, all the way up and through to the 2000s. And now Shell's building another one, the Whale Field out in Alaminos Canyon, and that'll be coming out here before too long. So here we are standing on the shoulders of giants. The industry has made 500 deep water discoveries in the Gulf of Mexico, and so far is producing 1.5 million barrels of oil a day. It's going to be even more than that in the future as it goes forward. We see just tremendous amount of discoveries, technologies by Shell and others over the years, and really just a very powerful story. And the other thing that's done is that's enabled us now to actually find, it's a very interesting question. We've been out here for 60 years, but now we believe that the potential for more hydrocarbon development is out here, such that the yet to find volumes, which is what this is in green here, undiscovered resources today, are greater than they've ever been before, even though we've been out here for 60 or 70 years. So it's a really incredible story that we've made a bunch of oil. We've got good reserves, but yet a huge amount of yet to find volumes. And these are going to be accessed by new technologies as we go forward. So with that, in conclusion, I think I'm out of time. Maybe I'm okay. So what is the conventional wisdom for us today in 2020? For me, as a retired guy, I have a chance to think about it in a little bit different way than some of you folks that are working hard on a day-to-day basis. But I think it's important to keep this in mind. What conventional wisdom is causing you to sort of be stumped in your business, and to was always those were fun times back in 1984 through 88, where we'd have lots of intellectual challenging discussions, a lot of people yelling and screaming and throwing things. It was a great fun to go over to Shell's Research Center and hear the old guys go through those machinations and debates. Very interesting. So for us today, though, we have conventional wisdom that we have to deal with. How are we going to access these yet to find volumes that are there? How are we going to meet this continuing increasing energy demand. And it's not going to be that we're going to put a windmill in everybody's backyard. That just can't happen. So we've got to have oil and gas to continue to provide in transportation. I know everybody's excited that Elon Musk is going to build in Austin we're going to have a Texas truck that's an electric truck, but the reality is these electric trucks and electric cars, they just obfuscate the issue. When you look at how what's required to build the metal as well as to build the batteries and other kinds of things like that, actually the consumption of energy to build one of those things is just as bad, if not worse, as a regular diesel powered truck. So it's really going to be an interesting challenge that'll be out there for you guys to refute. And I'll just leave you with this cartoon. Don't ever, ever give up. Keep working at it. Try to understand it. Here's these opportunities. I think it's an important thing for us to continue to push and to continue to disprove, among other things, the hoax of the anthropogenic global warming and other 15 hoaxes that educational folks believe today. Margaret knows about that from my Sunday school class. If you're interested, I can send them to you, or we can have another discussion. So the giants of the past, and now I'm one of those giants of the past, are saying don't ever, ever, ever give up. Stand on our shoulders, use people and technology to see past the conventional wisdom of today to tomorrow's opportunities. And again, just as a geophysicist, to remind you, seismic is the lifeblood of the EP business. And then with that, I'll close, and I'll be happy to entertain questions or comments as the case may be. I hope this was helpful for you. Thanks again for the opportunity.
Thank you very much, Barry.
Thanks a lot, Toby. Great presentation.
Sorry, Toby.
Yes, thank you, guys.
And would it be possible to post your email so I can email you?
Yes, I'd be happy to do that. I should have done that, but let me just, is there a way I can type it into the chat room maybe?
Yes.
Yes, do that. I just write it into the chat room.
Yeah, here we go.
Tarek or Alex, can you go with the Q&A as well, please?
Tarek will go.
Yeah, I don't know. I see Alex is here, and he's welcome to do that. But yeah, let's get started. I guess from Chris Mayo, he's saying, in other words, is geology generating oil now and refilling the geological tank? So are we looking at more revolutions in geologic thought beyond unconventional, and that is I guess it was Wallace Pratt, the famous quote, "Oil is found in the minds of men." So
yeah, that's right.
What's going on in the minds of oil finders these days?
Yeah, it's a really interesting question. Of course, we've gone through in the last 20 years the unconventionals, which is a completely different story that we find. And in many places, there's hydrocarbons in virtually every sediment layer in the subsurface that at least that is a sedimentary rocks, not igneous rocks necessarily. So there's a huge amount of discussion about how the oil is being generated, and then when it is being generated. There are some very interesting fields around the world that have continued to produce beyond their tank size, meaning that in fact there's something that's happening that's refilling those reservoirs in ways that we haven't really understood. So it's a really interesting challenge. Either that oil is resident at some deeper level and is actually migrating up to refill the shallower levels, or in fact we still have some continuous generation going on today based on the thermogenic properties in the deep. So it's a very interesting challenge, and one that I'm interested to see. I certainly read about that a lot, and I love to challenge my geology friends who oil is a recent phenomenon. It's not an old phenomenon. It's very interesting. Yeah, great question.
That's actually why I wanted to contact with you on the email, because there is a lot to discuss in there. There is a lot of science background and unresolved questions.
Absolutely. Lots of questions. That's great. I love to hear from you. So I put my email address in the chat box there, so you got it.
Sure. Thank you.
All right. Good.
Great. Salim's got a question. Why are most giant offshore fields in subsalt?
Yeah, it's a really interesting question. And in fact, the question really comes down to, it comes down to proximity to the source rock, right? And what we see is that the source rock is in a position where it's actually cooking up. It's like your kitchen. It's got a little heat going. It's got a little pressure going. And then it matures, and then it leaks up through the salt or around the salt or around faults that are caused by the salt. And that's where it actually accumulates. So it's a very interesting point, because in fact, up on the shelf, that was not the case. On the shelf, most of the oil that was found was above salt, not below salt. And so we've had to then develop drilling techniques and capabilities to drill through salt to find these subsalt reservoirs. So it's a really good point, but it just has to do with this sort of geometric effect. Again, gravity works, physics works. It makes sense. That's what's going to happen. Charles' law, Boyle's law says, if you've got liquids under pressure, they're going to try to float out, and they're going to find a place where they can be trapped in terms of the porosity and permeability. Good point. Good question.
But
Yes.
Toby,
If I add a comment here, actually, you pointed to it quickly. It comes out to the oil kitchen, the cooking of the oil, the source of rock maturation. And a lot of people consider the oil generation is related only to source rock maturation. But what happens when the salt diapirs develop? Is there any additional cooking for the source rock? Is there any more capping or oil migration assistance by the heat and the pressure that developed by the salt domes?
Yes.
So again, there is a lot of additional help here that we scientifically don't understand yet.
Yes, that's right. And I'm oversimplifying it for sure, but it's a great point. Good.
Toby, if you look at it, many of the supergiant oil field of the world, if you look back that Texas Panhandle, then somewhat lower oil field in Siberia, Western Siberia, Russia, these are supergiant field, but they are onshore, but they are not subsalt type. Onshore, salt can be in onshore environment as well as offshore, right? Like in
It's true, but the biggest oil fields in the world are Iran, and most of them are around salt domes in Iran. So, there's these giant, in Iran, there's these giant salt mountains that, are salt domes that are actually exposed with thousands of feet of relief. It's really interesting to see. Kirkuk and some of these other things, it's really very interesting to see what they are. So there are all types. I mean, I worked in Venezuela for a few years, and we actually, one of the biggest oil fields in Venezuela, we were producing out of fractured igneous rock, where the source rock was on top and actually went into the below, and actually we produced out of that. It was really a really phenomenal thing. So oil industry is really cool, and oil is in lots of different places. That's very good. Yeah, thanks. Good.
Okay, thank you.
Next question was from Doug Lair, and I'm going to ask Doug to clarify, because he's asked, what about APPO, capital APPO? I'm not familiar with that acronym.
He's talking about Appomattox, which is a structure, a facility that we've built in the deep water eastern Gulf of Mexico, and opened up a new play that was not being used before in the deep water, which is called the Norphlet play, which is an old sandstone. And in fact, it was producing, the Norphlet's producing up in onshore Alabama and Mississippi and places like that, but it's all gas because it's deep and it's hot. And what we found is that Norphlet sand trends out into the deep water, it cools off, and therefore you can have oil there. And we found, based on the persistence of some geologists, Ted Godo and a few, John Carlo and a few other folks, Shell went out and boldly went out and actually leased some blocks there and drilled some wells, made some discoveries. That, unfortunately, is not a amplitude supported pay, because those rocks are really hard. And so we just had to have the courage of our conviction. And as a result of that, we've drilled, I think, 9 or 10 discoveries out there, and APPO's out there, and it's producing like gangbusters. So it's really been a blessing. That whole Norphlet trend has been a great surprise and an encouraging thing for us. So it's another story in and of itself. It's a deep water story, but plus some. So it's really good. Good, thanks.
Salim, could you clarify this question? When did you move to advanced seismic at each 60 degrees on subsalt? I'm not exactly clear what the question is.
Well, what I meant, Toby, to get it, salt is a plastically deformable rock, right? So it flows. It's not elastically deformable rock.
Yes,
So
yes.
in order for you to find a trap, if you do 3D, 2D, or 3D seismic, that was not successful. But you have to move to an advanced seismic, which is probably done at every 60-degree angle. I forget what the term used for that purpose. Am I getting you correct? So when did you introduce that seismic technologies?
Yeah, it's a very interesting point, and it was due. What we found was that yes, it's right. There was a time early in my career in the 70s and early 80s where we could really only properly image about 45-degree dips, and so what happened was we had to get finer sample spacing both in an inline direction as well as in a cross-line direction, and then do full 3D imaging, 3D migration. So that was the requirement of that, is to have sophisticated models and to have lots of high-powered compute in order to be able to do those models. And so as a result of that, what we've been able to do is we've been able to take through the new imaging techniques, we can now image even overturned beds that would be dipping from the inline direction of 120, 130 degree dips now that we can image, which is really pretty cool. It certainly can image the near vertical dips of 90 degrees. You have to have long offsets because if you think about the physics of it, your ray paths shoot all over the place. So you have to have receivers out here to be able to collect that information, then use your model to put it all back together, your velocity model. So it's a very cool process, and really a lot of really good work done by not just by Shell, but lots of people in the industry. Good work. Good question.
Would that be for the development of the 3D seismic?
That's certainly 3D seismic was essential to be able to do that. That's right.
Okay.
Yeah.
Next question's from Henry, and he's asking, what are the main misconceptions proved wrong later in the Permian in West Texas?
Well, the thing was interesting. That guy, George Mitchell up there that did the woodlands and the work he did in North Texas there in the, what was that called? Not the Bakken, but the Barnett. Yeah, in the Barnett. What they found is that, as I said earlier, that there's hydrocarbons in lots of places, even so much so that even our well logs were not really sensitive to the idea that these very tight, low permeability, low porosity reservoirs, shales, and other kinds of things actually had hydrocarbons in them. And as a result of that, they found out that you could drill horizontal wells and then you could just put these million-pound fracks in there and crack them open and they would flow. It was an amazing thing. So they did the Barnett, and then they decided, well, the Permian is, along with other places, they went to the various other places around and went to Pennsylvania later and other places like that. But that you could go out to Permian, which is one of the richest basins in the world, to actually apply that technology, and then you could actually do that again, that technology, and then produce, and then find out that you can actually put these wells very, very close together because there's lots of hydrocarbons in a per cubic meter sense in these oil rich and gas rich shales, gas primarily. But it's really,
Toby,
yes.
Thank you for your answer. If you don't mind, can I clarify something?
Sure.
My question was more about the misconceptions. So like when you were speaking about the GOM, there were misconceptions that were proved wrong later. In the Permian, we always knew about the shale. The technology was not there. So my question was more about the misconceptions, if you don't mind, if you know anything about the Permian.
Yeah, I would say this is that it's a very interesting thing because, again, I perceive that, in fact, sadly, that the geophysics, which is what my background in, has not had as big an impact on the unconventional plays as we had hoped for in the beginning, because we just haven't been able to find the physics to actually resolve this issue. But I think the misconceptions were, frankly, the Permian, like the Gulf of Mexico, has been written off 2 or 3 times in my career. In fact, Shell owned and sold the Permian 3 different times in the course of my career, sadly, because we just didn't believe, we didn't have the the strength of our convictions to believe that there would be a way to technology-wise break that open and break that loose. So it became then a question of affordability and what's physically possible. And, you know, you only have limited investment, right? So you go other places where you think your investment might be more profitable for you. But it really is, it's an interesting thing, because I remember many times we had geologists and geophysicists pushing for money in the Permian, and they just couldn't get any from senior leaders because they just didn't see where the investment would be worth it. So it's a great.
Thank you.
May I make a comment on that?
Sure.
The major problem or the major misconception, or I wouldn't say failure, for seismic to work in the Permian Basin, that seismic traditionally is looking for structural traps, looking for the anticlines mainly, or the salt domes and such structures. Most of the unconventional plays are based on stratigraphic trap, on the sedimentation, not on the structure. And again, it is a play with the difference between permeability and fluid flow and porosity. So it's not, it's still the physics, but it's completely different physics than buoyancy and trapping in an anticline. But that comes back to a note that you said in the presentation earlier about production from the deep granite, fractured granites in Central America. That's the idea behind production from the shale, that if you fracture it, the granite is crystalline rock, is very low permeability, low porosity. If you fracture it, you can trap enough oil that you can produce it later. The same thing in the shale.
Yes.
So again, it's a completely different play game that seismic or traditional seismic per se would not fit in that.
Yes, great, thank you.
Toby, you talk about Permian Basin for Wolfcamp Shale. Yes, the repository for oil and gas as well. However, because it is so tight, permeability is that the production recovery factor is between 5 and 10%, as opposed to going into Gulf of Mexico's and other places where you can get up to 60 or 70% recoveries.
That's right.
Like in oil sands in Canada, Cenovus got 70% recovery in Athabasca oil sands.
Yes. No, it's a great point, and it all comes down to fundamentally the economics versus the technology versus the business opportunity, right?
Mm-hmm.
The one problem with the Gulf of Mexico is that it's great to find these accumulations, but there's not that many of them, right? And the thing that's amazing about the Permian is that it looks like there's hundreds and hundreds of square miles of opportunity there to be able to access. So it's a big prize, even though it's low recovery.
Yes.
Because 60% of the sedimentary rocks of the world is really shale.
Yeah.
Yes.
That's right.
We haven't even tapped it yet. So we just started to do it. My one other question to you is that you have gone in Gulf of Mexico up to a depth of 35,000 feet probably, right? And if you go beyond that, what is the transition when you're going to move from oil to thermogenic gas?
Yep. That's going to be the challenge, is that the question of how deep it is. Now, one of the interesting things that we have in the Gulf of Mexico, as well as in other places around the world, is God made salt with this amazing property that it's a heat sink, and it actually will pull heat out of the sediments and enable you to see cooler temperatures much deeper than you see in other places. And so the reality is that I think we're going to find hydrocarbon accumulations even at great depths because of what salt has done for us, if you can just find the right geometry.
Toby, hi, this is Francisco Pineda.
Hello, Francisco, how are you doing?
So far, so good. Great presentation, my friend. And I'm only going to make one point. There was a comment in this list that deserves an answer from you. The man says, let's see, this is more politics than training. Could you answer that, please?
Well, I apologize if that's the case. That was not my intent. My intent was to try to give a history lesson to help people understand the fact that we have had great success in the past, and I'm hopeful that we can have great success in the future. And I think the tragic thing is everything in our world today is politicized, but I think we can't be deterred from fundamentally the science. And I think that little paper that I showed at the very beginning about the energy density of oil and gas versus other energy options is critically important. I have to tell you, I have 5 kids. I have 4 grandkids. I'm hoping for a bunch more grandkids. And I don't want them to live in a world that is energy impoverished the way that people did 200 years ago. And that's tragically where we're going today with much of our political investments, because you can't overcome the physics. It's sad, but you can't overcome the physics in some of these other alternative energies. So I know that potentially can be viewed as a political statement, but the reality is I believe it is actually a science statement, not a political statement. So I'm sorry for the offense, and I
no, don't be sorry. Don't be sorry. That statement required an answer, because we stayed quiet for too long to statements like that. Yes. So I appreciate you answering that. Yes. There is no politics involved here. This is, hey, our jobs, our livelihood are in the line if we keep quiet.
Yeah.
It's not just our jobs. Our jobs, it's sad. I mean, it's hard to lose our jobs, but it's really civilization, and it's the need for the fact that impoverished nations in places like Africa, which are actually have lots of physical resources that could be used if you have the right kind of free enterprise system and capitalistic society that enables you to access those things. It's tragic to see. I spent 6 years working in and out of Venezuela, and Venezuela should be the richest country in the world. It should be. It has that kind of oil and gas resources, but tragically, because of the fact that they don't have a law and order society, that they wind up with, 99% of the people are living below the poverty level. It's just tragic. I should make a point about my background. I just wanted to make a comment of that. I'm not actually in a seismic vessel, but I grabbed a seismic vessel instrument room and I put it up so that would be a little bit authentic. So anyway.
All right. Toby, I really also appreciate the presentation, and there are other questions. Well, and I do have one question, and while I'm stating my question, I would like everybody to turn on their videos, and that way we can take some pictures. But my maybe question comment also has to do with something comment that you just made. Oil was made by God. It's there. It's not something made by man. So therefore, it must be good, something good of it. There is still more oil that we haven't been able to get, just like those misconceptions that you were mentioning. You didn't mention that all of those fields that are, beyond the 35,000 feet and have 25, 30,000 PSI. That's some amazing pressures that we're not able to produce because we're not prepared for that. Right. I worked in a project when I was at Chevron where we had to ask the casing manufacturers, hey, do you have this casing size to be able to withstand these pressures? And so and we couldn't. So they are in the process of coming up with those. I'm sure you worked on some of those projects that you found them, but you couldn't get it. So it's not something that it's something there in preparation for us. So it's got to be something good, right?
That's right. Thank you. I appreciate that. I'm sorry, my lawnmowers, people are outside here, so it may be a little noisy here, but I do think it's just a very exciting business to be in. It's just tremendously rewarding. And again, because it's really the battle against the earth, not just a battle against the individuals or other companies or that sort of thing. It's really an attempt to say, I agree with your point. God made the hydrocarbons in place there, and it's just, there's a verse in the Proverbs. I'm a Sunday school teacher, so I'll say it's the glory of God to hide a thing. It's the glory of kings to search a thing out. And so that's where we are. We're trying to search these things out to fully understand what they are and how they work. So thanks for that.
Toby, I have two questions. One of them I put in the chat, but it has never been presented to you. Well, first of all, one is that to add to what you already told, I don't think there's the politics in it. What you told at the beginning is that well, we know there was a time of global warming, then transgressions and then migrations and the sea level rise, sea level drop, and CO2 increases and decreases. In the geological history, it happened in the past, but probably some of that at the moment is much more enhanced because of what we have been doing, I guess. As to add to that, the other question I have is just a comment to what you presented. Next one is that you talked about oil accumulation in syncline. Has it been validated, or is just a down-thrown block of a fault?
May I comment on that, Salim? It was proven in unconventional. For conventional reservoir, the physics doesn't support it.
It's a good point. And in fact, what we find is most of the time, if you don't see a down dip fit to the structure, it's probably because you got the structure wrong. In the conventionals is the case. As you said, in unconventionals where you deal more with stratigraphic kind of situations, then you can see if you can get a structure map. Many times we don't even have a structure map, but if you get a structure map, you can find that if there is a contact, it moves everywhere. It goes all over the place.
Exactly. Exactly.
Well, to tell you that, then from my experience, but I cannot validate it at the moment, and Russians have found accumulations in syncline. And I don't think that was a heavy oil or tight. To the best of my knowledge, it was light oil.
I'm sorry, what did you say they found? What now?
Russians.
But what did they find? What did you say they found?
Oil accumulation in syncline as well, and I cannot validate it with the exact information. I have to dig it out.
Well, Salim, the only way that can happen if your syncline before developing, it was completely sealed by sealing fault and then it's folded. So it's saturated with oil, completely trapped on all sides by a trap rock or a cap rock or a structure, and then folded to syncline. And that will be a very limited and very localized anomaly.
That is true. Probably it's because of the fact of reverse faulting, right?
Exactly. So beyond that complex structure, okay, naturally it cannot exist in a syncline. Buoyancy will not allow it.
Yeah, I think so. It's a small accumulation, probably it would be. Yeah, that's what I thought it was. Yeah. Thank you.
Eva's got a couple of questions. I'm sure he's been waiting patiently for answers, but the first of which is, what's your take on bypass opportunities in and around old fields and wells? How much was left unproduced due to being considered non-commercial or technical production?
Well, I think there's great opportunity because frankly, in many places, particularly you look up on the shelf in the Gulf of Mexico and other places that are considered quote unquote mature basins, that the new seismic and techniques and imaging capabilities developed out in the deep water, if you could use it up in the shallow water, you'd find opportunities that would be much greater. My son used to work for BP, and he's actually now, he took a severance package, as the case is sadly of a lot of guys, and he's trying to start his own oil industry company, and he's out prowling around in small salt domes in the Texas Gulf Coast. And what you see, it's so interesting that the seismic, even though these fields have been discovered in the 1920s and 30s, but the seismic is so poor that you, just a matter of in many cases, just re-imaging, reprocessing the seismic really brings out opportunities that in these little bitty salt domes that have hundreds of wells in them, they've missed some really interesting remaining targets and opportunities. So there's a huge amount of redevelopment activity that's available. Sorry, I apologize again for my, maybe I'll put my earphones on and then you can see it here.
While you're doing that, Toby, Siva has another really good question. And
sorry,
he's asking,
Okay, he'll be gone in just a minute.
Yeah, It's not that bad.
I'm really thankful for these guys because I don't have to mow my yard anymore. It's very nice.
Oh yeah. I was just saying that Steve has another good question about asking your advice to fresh graduates as well as mid and late career geoscientists who want to stay in geology, and particularly in oil and gas geology, but are getting frustrated not having the opportunities to either enter into the industry or stay in it. So what do you think?
Yeah, it's so sad. It's such a tragic situation, and I'm still on LinkedIn, so I see lots of folks that are just struggling mightily and having to do career changes and so on and so forth. The oil industry has been very good to me and to my family, and great opportunities. But I do think that the important thing for us to do is what's been the case for me over the course of my career is that you just got to realize that, in fact, it's cyclical. It's hard but you can potentially go for 2 or 3 years without great opportunities. And then you see, just like the price of oil going up and down. I mean, I don't know you guys are watching, but a lot of people are saying that once the reopening happens, we're going to see $60 barrel oil again. I mean, it's just amazing what can happen to us, but you got to have some kind of capability. I appreciate the fact that the first talk today was about franchising and other kinds of things, because it almost seems that you have to have sort of a fallback position in some of these difficult days. I have many of my friends that struggled. They couldn't make it all the way to the end, and they've had to go and do career changes. And I know that's a very, very difficult thing. I wish it were not the case. I have to say, as I said, it was definitely a rewarding career for me. And in fact, my son, I went through the 90s telling my wife, as we talked about, I'm not going to encourage my sons to go into the oil industry because it just seems too unstable. I mean, we had 10 or 11 or 13 layoffs in the course of my 39-year career. But in the end, where he was at, and based on what his interests were and that sort of thing, he went to Texas A&M. He got his petroleum engineering degree and got out and had 9 really good years with BP before things kind of fell apart for him. But he built some skills and some techniques where he's now in a smaller game. And I have to tell you, it's a very interesting world that he's in. But in the end, he's producing oil and gas in places that others have he's standing on the shoulders of giants, but have given him great opportunity. I'm not saying that's the case for everybody, but I just think it's important. I believe, as we talked earlier, Carlos, that I think God has a plan for your life. And so I, encourage you to follow it and to recognize that little cowboy wisdom that people are like watermelons. You don't know what kind of character they have, how good they are, till they're thumped. And we've been thumped a lot in the oil industry over the course of the years, and in particularly these last several months. I know it's very difficult. So I'm definitely in prayer for all of you as you go through these difficult days.
Yeah, Toby, I think, a combination with a previous comment on the opportunities, and maybe there is enough wisdom here and in this forum that there is what we call depleted wells. They are not depleted, or most of them are not depleted. I used to hear 40% of the oil is still in those depleted wells. Now I'm hearing 70% of the oil is still in those wells. So there is a lot of opportunity is there. So where do you fit in that as a young person? There's still a lot of opportunity in my mind.
That's right. And unfortunately, because we're in a commodity world, that it's a function of the economy, right? And I know people get tired of hearing Trump say how good the economy was before COVID, but it was true that we were seeing a great increased demand for lots of commodities and a really nice price here before the last 7 or 8 months, tragically. So hopefully we can get this stabilized, get the economy back going again, and be able to go forward. So anyway, great point.
Toby, when is the chapter 2 of this presentation? Before the elections or after the elections?
Well, I don't know. So Francisco, where are you from? Are you from Venezuela or where are you from?
No, I'm from Honduras. As a matter of fact, I'm the brother of Carlos.
Oh, you are? Okay, very nice. Okay, from Honduras. Well, I tell you, I have such good friends that are from Venezuela that are in the oil industry. I feel so bad for them, but I really am concerned about this election because here's my political statement again. If you're offended, go ahead and close your ears or something. But I think if we vote for a certain party, we're doomed. I'll just say that, and I'm talking about at all levels of the whether it's for dog catcher all the way up to president. I think that you can't vote for a certain party. I'm sorry, it's not just because I'm an oil guy, but lots of reasons. All right, sorry about that. You guys can't fire me. I'm already retired, so it's okay. I'm happy to have that conversation, Francisco, at another time, but maybe perhaps not here. Might not be the right forum. So,
may I make a comment or maybe an advice on what you just said?
Sure.
Everybody is entitled for his opinion, yes, or for his affiliation or if his choice, but none of us is entitled to the facts and the science. Yes. So we need really to resolve our problems by sticking to the facts and the science, not to our opinion or affiliation or interests.
Yep, that's my cowboy wisdom point number 2, right? Stay with the facts. Exactly. Good.
And the science will help you explain the facts.
That's right. Exactly.
And yet you believe in God with no evidence.
No, there is a lot of evidence.
There's no evidence.
I'm just coming back through the list of questions, and I realized we skipped one from Siva, and that he's asking what other basins outside of the Gulf of Mexico and the Santos Basin are you expecting major discoveries to come from? What's the next super basin in the conveyor belt? Yeah, sorry, my lawn guy's leaving. My phone starts ringing, so I apologize for that. But I tell you, what we did in the last few years I worked for Shell, it was very exciting things going on in Brazil. I think that Brazil has huge opportunities. Tragically, again, their political situation is very difficult. We've seen, sadly, just sad news for Exxon and Hess in Guyana in recent days. It's just that there's so much opportunity in these new basins to be able to go and do things in amazing ways. But tragically, if the government systems can't be set up to be able to handle this wealth as it comes in, it leads tragically to corruption. And Shell's seen that over and over again in Nigeria, tragically, and places like that. So I think that there is still good opportunity in deep water in the conventional. I think, as we mentioned earlier, redeveloping in existing super basins like the Gulf of Mexico is still a great opportunity. I think the unconventionals is one of these things that are still good opportunities if we have the economics and the price to support it. You know, one of the things that we found with this, it's a giant manufacturing problem, right? And you need to have, in order to be able to make money, you have to spend, you have to have hundreds and hundreds of rigs working at any given time in order to be able to justify that investment, which in certain cases looks good to Wall Street investors, but tragically when gas prices, conflate down to $2 an MCF, you wind up with really difficult financial situations. So there are really still some very interesting opportunities out there, and there are a few guys that are out pursuing those. I think there's clearly basins. You look at just the African coast, the deep water, sort of take Nigeria. We've been going Nigeria to the south and Angola and places like that. But if you go to the west and you look at Ghana and you look at places like that, there's still lots of opportunity there that's really underexplored.
Can you comment on the opportunities in the East Mediterranean and Egypt, for example?
Yeah, no, that's a really great one. Those guys at Noble did an amazing thing because they went out there and found these giant gas fields, and it's really changed the economics of that whole area now. And to think that now Israel is actually exporting oil to, I mean, the gas
to Europe, yeah.
in Jordan is just an amazing thing. Who would have thought that was the case 20 years ago or even 10 years ago? And now, of course, Noble has made themselves so attractive that they now Chevron's buying them out. So it's very interesting. But then they've found these fields up in Cyprus and places like that also. So that's a very unexpectedly rich basin. And so these are the kinds of things that suddenly make appearances because people are challenging the conventional wisdom. I have to tell you that I never did work in Egypt, but Shell spent a lot of money looking in deep water Egypt trying to find these kinds of opportunities. Sadly, weren't able to do that, but the Noble did in the Israeli offshore. Very interesting.
Yeah, yeah.
Don't you agree, Toby? Along the divergent plate margin, there is expected to be a lot more discoveries.
Say again now, Salim, where to have discoveries?
Along the divergent plate margins.
Yeah, I think so. I think you'll see, anywhere in the
conventional,
anywhere where you can see there's an opportunity to get sand deposited, you're going to be able to find places. And of course, we're still seeing things in chalks and limestones also. So very interesting. Yeah, right.
Mm-hmm. Yeah, that's right. Chalk is highly porous, right?
Yeah. Yes, that's right.
I can't see any more questions per se, but there are some interesting links and bits of information that people have been embedding in the chat. And if you pull down on the ellipsis at the bottom, the three dots at the bottom right of the chat window, there's an opportunity for you to save the chat if you're interested in those links or email addresses and such. I've just done that for myself, so just a reminder. And I'll hand it back to you, Carlos.
Well, thank you very much.
One last comment, excuse me. Toby, did I hear correct that I should vote the cowboy wisdom?
You got it, Francisco. That's it. It's a cowboy wisdom, not conventional wisdom. Thank you. Or cow person. You can be a cow person if you like.
Yeah, thank you. I'm going to start the recording at this point, and I'm going to leave it for Salim.
You have